this is going to be a video going over an example where we implement a copy constructor and assignment operator for an object. And so let's go ahead and take a look at what we have here. And so we have two files, main and person.h. And so we will be talking, including student.h later when we discuss inheritance, but that'll be later. And so just examining what the person has, it looks like here's a class person. I have a couple functions. He has one single member variable, which is simply a pointer to a book. So he will store an address to a presumably a dynamically allocated book. And so now a book is defined as a struct. And then we know at this stage that a struct is functionally equivalent to a class. They both allow us to build abstract data types. And they can do everything. So a struct can do everything a class can. The only difference is that a struct is by default public. So meaning I don't need any access specifiers here if I want these things to be public. And so anyways, a book consists of two member variables, a title and an author, both strings, and they're non-pointers, and so that we might be able to use that to our advantage later down the line. However, though, to contrast that, a person does have a dynamically, well, he has a pointer to a book, which in and of itself isn't necessarily indicative of anything that we need to consider by way of, well, in terms of what we need to copy. It's only if this thing will store addresses to dynamically allocated memory, which in this case it does, which is highlighted here. Now, which is to say that if it might be that a person could be pointing to an already existing address, right? That's a possibility, in which that meant he did not allocate that book, or I guess you could say this person would not have owned that memory in the first place, meaning he wouldn't have any responsibilities with regards to its management. But that's sort of besides the point. In this case, he does have a pointer, and it does point to dynamically allocated memory that he, in a certain sense, owns. And so he is responsible for it. And so now, let's go ahead and construct P1 as we see in main here using this first case. Right, so person P1, here he or she is in memory. Again, the new operator will allocate effectively this. And again, just as a side note, we know now that the new operator for objects will invoke a constructor, in this case, the default constructor for books. But there's none here, so we get the implicit one, which does nothing. And so it's all besides the point. Subsequent to all of that, though, we do dereference XAA, get the member, using the arrow operator. And so just remember, this is doing the exact same thing as dereferencing the address and then getting the member at in that box, right? And so this combines those two operations. And typically, you're going to be using this, right? This is a bit easier on the eyes, easier to read. And so this is preferred over this, but just know that they do the same exact thing. And so I'm getting the dereferencing this, going to this box, getting the member title, and setting it to story of B, which I already did. And same thing with the author, Daniel Quinn. Incidentally, a pretty good read if you like anthropological fictional stories. It's pretty nice. He also has other books, Ishmael, which is about a talking gorilla. Anyways, and so let's go ahead and go through and construct P2, and let's go ahead and analyze this first. And so we are making a declaration for a person P2. That means it must be a constructor, right? And so when you think declaration, think construction for objects. It can't be any other function. And the reason that distinction is important is if you could instead use this syntax, that would effectively be exactly this. It's just a different notation for, well, the same process. The only thing that may be confusing to people here is that we're using a different symbol. And this might debate people into thinking that this is the assignment operator. And unfortunately, that's not the case, and it can't be the case. And the reason you would know that it can't be the case is the fact that this is a declaration. And again, when you see declaration for objects, you must think constructions, or that is to say the constructor function. So one of these bad boys. Now in this case, because of the argument that we're passing to it being another person, that means we're using this function, which is what we call the copy constructor, right? So constructor, same type of thing, copy. And so now let's go ahead and see what we need to do here. So now, if I didn't have this, like for example, if I did not implement this, we would have gotten one from the compiler, right? Which does, given that the intent here is to make a copy between two like things or two similar objects, it's enough information there for the compiler to infer that you want the member variables to look alike. And that is the definition of a shallow copy. But the issue here is that in the case of having pointers point to dynamically allocated memory, a shallow copy would have resulted in P2 also pointing to P1's book, and again, this is typically not desirable. Well, certainly in this case, and I think in the majority of cases in which you have these sort of concepts within your code base. which isn't to say that it will never be a circumstance in which you might have different objects point to the same thing. It's just in those situations you have to be a little bit more careful about, well, who owns that memory and who handles the management of it. And so again, for this, just so we can understand just the basic ideas of just this, what is presumably new to some people, we're just going to assume that everyone owns their own dynamically allocated memory and are responsible for it for themselves. And so this is bad given that scenario. And so, and again, this results in a bunch of issues, and we examined that when we discussed that in lecture. And so this is bad. A shallow copy is bad in this circumstance. And so, boom. What we want to have instead is what we would call a deep copy, meaning P2 would not have a handle onto P1's book or alias it. P2 would effectively want his own book. So that would mean he would have needed to made a call to the operating system requesting that memory. Let me go ahead and clean this up. Right, and so that is done through the new operator. And so that is to say, at some point within the function I deleted, I'm going to bring it back, we need to make a call to new someplace, right? And in which case we could, well, it's pretty straightforward here. We need to allocate one new book. Again, this is a simple example. It would be a bit more involved if this were an array, but I don't want to spend too much time on that because it's somewhat besides the point. So we dynamically allocate a book. And then from that, we need to store that with a pointer. So in this case, my book, I don't know why it's commented. And so we need to bring this back. Oh, I know why. Because before doing this, it might be, and again, depending on what your design is, depending what preconditions you might have for the object design, you might have some edge checks or some cases, so edge cases that you want to check for, right? So you might have some edge cases, right? And again, this depends on a lot of different factors, and so this, in a general sense, you may, you might have this, you might not. But if you do have it in this case, maybe I guess a reasonable edge case condition might be that if the other person's address or the book that they're presumably pointing to is actually no book at all, right? They might have no book. And so boom, and in this case, if this were true, then chances are, if my goal is to look like the other person, that means I too do not want to hang on to a book. And so my book is also no book at all. Boom. All right, so one possible edge case, and again, there's not many because there's only one member variable here. With more member variables, there might be more edge cases, and so just be a little careful of that semicolon. Okay, and so assuming just normal operation in which P1 does have a book, and then so let's go ahead and go through the business where, well, I can. First of all, P2 is pointing to XBB now, right? After the execution of this line. Assignment XBB to my book. Boom. And I can dereference XBB, again, using, let me go ahead and use this syntax. Dereference XBB. After I dereference this, that means I go to the box at XBB, which means I'm standing here, which means I'm now looking at a book for which I can get the members of. In particular, I can get the title using the dot operator, and I can assign to it. If I want to use the similar dot or dereference dot notation, this is a bit more wonky, right? And so again, well, let me get the other person first. So other person and then their address, the address of their book. And so this whole thing translates to XAA, right? That is to say, you don't dereference this because it doesn't make any sense. You have to dereference this whole thing. And so the order of operations here is that the dot operator happens first. So the dot operator will get the address, this converts to XAA, this dereference takes us to this box for which we can get the member title. And we're simply reading it to put it into this guy's book, or this guy's book's title. But at the same time, you know now that you can combine those two operations without the fuss of trying to just remember the order of operations between dot and dereference and whether or not you're dealing with an object or an address. Arrow operator makes life easy. So for the author, boom, author equals the other person's, my book, dereference, get author. Boom. Now, with all that being said, we could also use one additional information to do the exact same thing without any of this, because remember, similar to, actually, I'll wait till we actually implement the other function, because I don't want to mention it just yet, but there's another way of doing this without actually having to go through and get the members by using, well, what we understand about what the compiler gives us. But again, I'll save that until I get to, to be continued, right? So to be continued. Anyways, and so we'll leave off, we'll come back to this. Let's go ahead and talk about the other use case. Oh, let me go ahead and actually fill this out. So yeah, so this will get the title, boom, and then get that, boom. All right, so now we could say that P2 looks a lot like P, or exactly like P1, in that they're reading the same book, right? And so, and again, we have to be careful. Shallow copy, not good in this case. Deep copy, okay. So case 2 is this, where we have, well, the one observation that I kind of want to throw out there is that this is a case in which, again, P2 up until this point is not existing yet. He's brand new, or will be brand new. And so we need to give him all these things. In particular, that implies that because he's brand new, or I guess newborn, he doesn't have anything with him already. And so put that in the back of your mind. So P2 is brand new, and we're making him look like someone who already exists, right? So that's a use case. For this case, both P1 and P2 exist. And again, the observation to be made here is that P2 has his own things now at this point when we get to this line of code. And that implies that, well, the difference here is that he doesn't have things here, he does have things here. And so to make him look like P1 in this use case scenario, he needs to clean up the things he already has. And so again, this is a pretty simple object, and so there's a few things we need to talk about, but cleaning up is for the most part pretty straightforward. If you have more member variables, or if you have an array of things, it's much more, I guess, in a certain sense, complicated, because there's more to do or more to consider. But just bear in mind that it does whatever it means with regards to cleaning up after himself depends on, well, what he needs to clean up. Anyways, and so now that is to say, let me go ahead and set up the memory for this condition here, or this use case. So P1, let's suppose, I don't know, let's say speaker for the dead. For speaker for the dead, and then is that Orson Scott Card? I forget. I think it is. So let me go ahead and create some more space here. That, and then let's suppose again, this is sort of like this bit where we're doing some. They exist, and so they're walking around in the world, and they're doing some things and reading different books, right? And let's suppose he's reading Malazan, Book of the Fallen. I'm just going to shorthand that, and then that's by Erickson. Boom, and so boom, there they are. They encounter each other at a book club or whatever. Like P2 says, "Oh, you know what? That's a really cool book. This is kind of Gardens of the Moon is kind of hard to read, and so I'm gonna go ahead and just start reading your book because it's an easier read." And I'm going to put that down. So Gardens of the Moon. It is a hard read if you know anything about these books. I couldn't get through this the first time. And then after a while, I sat through it a second time, but then after that, I was locked in. And I read the whole series, and for me, this is like the pinnacle of epic dark fantasy, or grimdark. It's amazing. It's an amazing series, and I think part of it's because Erickson was an avid role player with his friend. The two of them got together and used the role playing world that they created. And then just create this world from it, just like Tolkien with his the Silmarillion and Lord of the Rings. Anyways, besides the point. And so now, given all of this, we need to, when they encounter each other, we need to do a few things here. And again, it's kind of, this is a cartoon example, and so when we talk about cleaning up the book, in this case, this specific example, because we know that everyone in this world only has one book, you probably could just reuse this memory. And there's many scenarios for which that might be true, but in a more general sense, that we're just gonna delete it anyways, because it's just gonna, you're probably gonna do that, especially in a case when we're talking about people who have an array of books, right? So people with different number of books, we have to reconcile the size, right? In particular, in a case in which, supposing in the example that P1 might have an array of 10 books, P2 might have an array of maybe only 2 books, there's no way for me to copy 10 books into 2 spaces, right? And so in that case in particular, P2 would need to certainly delete his array and reallocate enough for 10 books. But yes, just we're gonna make this fairly general to handle that particular situation. But just understand that sometimes maybe you don't have to, if you understand certain invariants with regards to your object itself. Anyways, and so now let me point out the blueprint. That way, or the pseudocode, that way you can just carry the pseudocode in your mind, and you can kind of paste that into every object for which you need to implement these functions. And that way you don't need to sort of try to remember what needs. It's a matter of just translating the pseudocode after that point. And so first thing I want to point out is that you have to remember that for C++, there is a return value, a return type to the assignment operator, right? So here's the function name. This is the return type, right? So person reference. And so you need to have a return value of a object reference. And the object is, well, the object that you're implementing, so a person, right? So person reference. Now, which isn't to say that you can't implement an assignment operator overload. By, you know, you can certainly set this to void if you don't want to return something, but that just means you can't do certain things like chaining assignments, and you likely can't interact with other with certain C++ libraries, because they will expect this to be true in many circumstances. And so I don't actually see any disadvantage in just always doing this. And so I'm just going to make the ruling in this class that this is what is expected of you for this function, for this class, and likely for every object that you write, because I mean, you're going to be dealing with C++ libraries, right? It's kind of unavoidable. Anyways, or the libraries for which they expect such return values. Anyways, and so with that being said, you need to reconcile this with actually returning something, and that ends up being a statement, or the way I phrase it is you need to return yourself. Or if I'm this object, return myself. We'll translate that in just a moment. Return myself. Now, in terms of filling the rest of this out, there's a few things we need to consider. A strange edge case. Well, certainly this is one of the edge cases that you will always need to include within the assignment operator. This will not exist within the copy constructor because it can't happen due to the use case scenarios. And so you need to check to see if you're assigning you to yourself, right? And so self-assign. Check for self-assign. Boom. All right. And so obviously that can't, this self-assign thing can't occur here because you don't exist yet for you to make a copy of yourself, right? So that it can't be done. Here it can happen because you can you do exist, and you can be by way of crazy amounts of hidden, or not hidden, but just through various function calls, you might be routing you to yourself if you're not careful with what you're doing. It happens more than you think, and so you need to check for it. And so in this case, if you are happening to make, well, I'll talk about the details afterwards. So check for self-assign. Now, in this case, you probably want to, this is where you clean up, right? So clean up. And again, the translation of this is typically deleting something, and specifically for the example, we're going to delete this book, but we'll get there in a moment. And the intent here is effectively to kind of start fresh, right? To make the object as if it were new, start fresh. Like a brand new canvas to allow you to resemble another person. And so that whatever that means will be determined by what member variables you have and what is relevant in terms of what you do by way of your copying. And so that's a bit abstract of a statement, but I think the more examples that you see, the echoes of this might become more clear throughout that process. But anyways, so start fresh. And so now here, effectively, after you start fresh, it's kind of, to a certain extent, as if you're declaring yourself anew, as if you would behave as if you're invoking the copy constructor. And so why not just copy all of this down here? Boom, right? And so copy constructor code, same business, right? Because effectively you'd want to do the same thing. Now, edge cases are likely the same if you have them, so I'll go ahead and carry that down here. And so, yeah, I mean, this looks like it, right? Because after you check for self-assign, if you're not self-assigning, then you clean up after yourself. That is to say, we get rid of this. Let me go ahead and get rid of this. I'll just delete it like this, so clean it up. We request possible edge cases. If no edge cases here, we go ahead and allocate a new book. And so let's say this is now XCC. And then we go ahead and get the title and the card, or the author, sorry. From the person, this is also a book object. And then after this, we return ourselves, and then we're done with this process. Okay, and so now let's go ahead and translate the rest of this. Self-assign is pretty straightforward. The manner in which we ask this question is somewhat indirect, but it should make sense in that the only most straightforward way of doing it, which might not be straightforward in terms of the way you might think, but you want to check to see if you're standing in the same place as the other person, right? So am I standing in the same place as this person, or is my address, right? So this is a pointer to my address, or rather, you can think of this keyword as for every single object, there is a pointer called this, where it stores the address of the instantiated object, right? So this is kind of hidden, and you have implicit, or you have access to it, right? You can call it within any function or any class. And so that is to say, when we declare P1 has an address in memory, wherever it is. This pointer, let me go ahead and throw this here. Let's suppose P1 is standing at, I don't know, like X03, or no, 02. That is to say, this will then take on the address of X02. Right, so that's all it is, just a pointer to the instantiated object. And so now, that is to say, I can use this to ask if I am standing in the same place as the other person. Boom. If this is the case, I do effectively nothing, because if you think about it, if I'm trying to make me look like myself, I should look exactly the same at the end of that operation. And so that's the same thing as doing nothing, right? And so in other words, I just simply need to reconcile the return value, which is to say return myself. All right, and so that is to say, understanding that this is my address. When I dereference my address, it becomes myself. It is my box, and so I'm simply returning me. All right. Again, the lecture discusses the details in terms of all of this, or has slides on this, so you're welcome to take a look at that. Now, given all of this, well, yeah, I'll leave this here. P2 has every object has this. The only place in which is actually required, other than various conventions that might be adopted by whoever you work for, is the assignment operator. Everywhere else, it's optional, right? So I could say this. Right, I could dereference this to get my members, but again, it's completely optional at this point in this location. Okay, and let's go ahead and so cleanup. In this case, cleanup is pretty straightforward. I only have one member variable, which is a single book, and so I use the single delete to clean it up. And again, as I mentioned, whether or not you do this is dependent upon a lot of factors. In this case, if I know for a fact that every single person in this particular program only ever has one book, then maybe I don't need to do this, right? Like I likely do not, because I can just reuse my memory location, and so I don't need to do this or this. I just, well, actually, yeah. So I just allocate, make sure I have the space for the book at some point, book, not bull, for which I can just reuse that every time I want to look like some other person. But just to be general, I'm going to delete the book, reallocate it, and then copy over everything that was there. And then let me go ahead and simply reconcile what we already talked about, which is simply to return myself. Boom. Okay, and so now this is the assignment operator. And one last bit, and now that we talked about the assignment operator, and we know that the only circumstance in which we need to implement any of these functions, well, actually, the assignment operator, the copy constructor, and also it turns out the destructor is when we have that's called a rule of three, is if we own dynamically allocated memory, and that's obviously it must be stored within a pointer, right? And so those two conditions. Now, if you don't have that, all right, for example, this book doesn't have any dynamically allocated memory, it doesn't have any pointers, so it can't have any dynamically allocated memory. And so instead of actually doing this, I could have just said get my book, dereference my book, and just do a shallow copy from the other person's book. All right, I need to dereference this whole thing like this. Boom. Right, and so this would have alternatively done the exact same thing as these two, because it's a shallow copy between member variables, right? We would have gone from title to title, author to author. All right, same thing down here. So just a minor point, right? So you can use shallow copies for objects that just have non-pointer member variables that don't point to, or if they have pointer member variables, and well, I already talked about it, you can figure out the negation of that on your own. I don't want to trip up over it. But yeah, so yeah, same business. This is the same thing as this because books don't have any pointer member variables pointing to the name of the allocated memory. Okay, that's it. Hopefully this is straightforward. I might have started picking up the pace of my speaking a bit, but I think you can slow it down within YouTube. But anyways, I hope this is useful. If you have any questions, post on the discussion forums. Yeah, and I will be coming back to this example when after we talk about inheritance. And so there will be some nuances, or not a few, but really only two new things that will be different in the context of inheritance. But there's a few things we need to discuss with inheritance before I get there. And so I'll save that until after that point. Okay.